Hi dear children, welcome to chemistry class. Till now, we learnt about hydrocarbons and nomenclature. We have only learnt about the nomenclature of hydrocarbons which could either be saturated or unsaturated. Well, we all know that carbon and carbon compounds are present everywhere around us, right? When we say hydrocarbon, what does it exactly mean? It means that the compounds are made up of only carbon and hydrogen. But tell me one thing, are there only carbon and hydrogen in all organic compounds? Are there no other atoms other than the carbon and hydrogen? No, right? So, what do you understand from this? Other than carbon and hydrogen, there are certain atoms present in this hydrocarbon. Today we are going to learn about such compounds and their nomenclature. So let's start. The structure of an alkane is given. What is the name of this compound? Yes, ethane, isn't it? In this hydrocarbon, carbon and hydrogen are the only elements present in it. Am I right? Now examine the structure of other compound. Observe the structure closely. What is the difference in these structures? In structure 2, which atom is there instead of hydrogen? Chlorine, isn't it? So, if chlorine replaces the hydrogen atom from an alkane, then the resulting compound will be chloroalkane. Got it? And if fluorine comes instead of hydrogen, then it is fluoroalkane. And if bromine, it is bromoalkane, and iodine makes it iodoalkane. See, the chemical and physical properties of all these compounds will be quite different from those of ethane. Understood? Let's see the structure of another compound. What comes instead of hydrogen in this? You can see that a group of atoms, right? This OH group in this compound is called hydroxyl group. If hydroxyl group comes in an alkane instead of hydrogen atom, then the resulting compounds are generally known as alcohols. They are called alcohols. Here also, the physical and chemical properties of the newly formed compound will be entirely different from that of ethane. So from these examples, what do you understand? Carbon and hydrogen are not the only elements present in organic compounds. There are other atoms and group of atoms present in the place of hydrogen atoms in organic compounds. The presence of certain atoms or groups impart certain characteristic properties to organic compounds are called functional groups. Understood? So what are functional groups? The presence of certain atoms or groups impart certain characteristic properties to organic compounds are called functional groups. Now let's get familiar with some of the functional groups and their symbols. Look at the table. The compounds having OH hydroxyl group as the functional group are commonly called alcohols. And the compounds with the functional group COOH carboxylic groups are known as carboxylic acids. The next functional group is alkoxy. Ethers are the general name given for the compounds with the functional group OR. And if fluorine, chlorine, bromine, iodine comes as the functional group, such compounds are generally known as halo groups. Okay? Let us see the functional groups in detail. The functional group that we are going to discuss first about is hydroxyl group. The compounds having OH hydroxyl as the functional group are commonly called alcohols. All alcohols have OH group and have the same properties. The presence of OH group in the carbon chain is the reason for the important properties exhibited by these compounds. Dear children, the naming of alcohols is done by replacing E from the name of the corresponding alkane with the suffix OL. So remember, the suffix OL is used to represent the functional group OH. In this compound, the first part in the alkane represents the number of carbon atom, whereas the OL in the suffix indicates the alcohol OH. Understood? Let us see more examples. Consider the alkanol CH3OH. The IUPAC name of the compound is methanol. See, there is only one carbon atom in this compound, right? And one of the hydrogen in methane is replaced by the functional group OH. Hence, the IUPAC name is given as methanol. See another alkanol CH3CH2OH. Here the hydrogen present in ethane is replaced by the functional group OH. So the IUPAC name is ethane minus E plus oil gives ethanol. Got it? Now observe these structures. What is the molecular formula of the structure A? Yes, you are right. C3H8O. And what about the structure B? Again, C3H8O. So what difference do you observe in these compounds? Very good. There is a change in the position of the functional groups, right? So if there is a change in the position number of the functional group, there will be a change in the IUPAC name also, right? So always remember, while writing the IUPAC names, the carbon atom having the functional group should be given the lowest position number. Now see the position number given to the carbon atoms. Which way of numbering is the right one? Yes, from right to left, so that the carbon atom will get the position number as 1. The IUPAC name of the compounds with OH follows the pattern alkane minus E plus hyphen plus position number of OH group plus the suffix OL. If so, can you say the IUPAC name of the structure A? Yes, it is propan-1-ol. Understood? And what about the structure B? The IUPAC name of the compound is propan-2-ol. Here, the OH functional group is present in the second carbon atom. Hence, the IUPAC name propan-2-ol. Is that clear?